Now, within this one was actually relatively simple to decipher which one is your X and your Y because they call it cabinet X and cabinet Y. And it was very clever, and the fact that the X cabinet came before the Y cabinet. You guys move away from the window so you just keep running. So we know we have X cabinet, Y cabinet. As you read through it, they want to maximize storage volume. Okay? So the storage volume is the capacity of the cabinet itself. So you have to go back and reread the question then talking about cabinet X and cabinet Y to get your objective function in relation to volume. Cabinet X has how much volume? 8 cubic feet. Cabinet Y then has 12 cubic feet. There's your objective. Okay. And then you reread one more time, you'll notice they talk about two separate things. They talk about money and square footage. The money that you have up to, and it includes spending, is $140. And then it says the office has room for no more than 72 square feet of floor space. So that's your other constraint. Those are your two that you have to worry about. Let me go back in and fill in the blanks. Well, cabinet X cost $10, cabinet Y was $20. Cabinet X had 6 feet of floor space, and cabinet Y had 8, I think. Is that right? Yeah, 8. And now we have to plot. One of the things that I would do right away here is notice that first equation. They're all multiples of 10. I would just take out the scalar to make it a little bit easier on myself. Plus, then when I go back into substitute and do the algebra, it's just going to be a little bit cleaner. Do you have to do it that way? No. Just for mental math purposes, it works out a little bit nicer. Was that 14? Okay. So now you know your intercepts. You've got a 14, a 7, a 12, and a 9. Are we okay with that? All right. Hopefully, intercepts are getting easier and easier and easier to do. That's scary thought. There you have our constraints up. I have a 14. I have, this one goes to a 7. And it's moving inward. Okay? The other one has a 12 and a 9. 12 for X. And a 9. Lo and behold, they run into each other. Ooh. So what I would do is you'll notice that since we took that scalar out of the original equation of 10, I'm going to say that X is 14 minus 2y. When I do stuff like that, I like to use substitution a lot of times with this, just because to me, it seems easier. You don't have to use this method at all. It's just what I've always done. So I would write in here 6, 14 minus 2y, and 8y is 72. Mathing all of this out, you wind up with 12 is 4y. You get y is 3. 2 times 3 is 6. 14 subtract 6 gives you 8. And then that gives you your boundary to test. You get what, 8, 0, 0, 7 centimeters. First one will be 84. Next one is 64, and 36 is 100. And the last one is 96. So 8 and 3 it is. You need 8 of cabinet X and 3 of cabinet Y. Woohoo is right.
That's right every morning.
What's wrong, Trinity?
Can you just actually
Try substitute. Okay. All right. So next one was about practicing soccer and football and getting paid for it. And in the wrong business. True. So Josh practiced football and soccer for a maximum of 15 hours a week. He wishes to spend 2 to 5 hours on soccer. He wants to give at least as much time or more time to football than soccer. Josh's uncle will give him $3 for every hour of football he practices, and his grandma will give him $4 for every hour he plays soccer.
What is it like bribing you to practice?
One sport more than
I don't know. What is the maximum amount of money Josh can earn by playing these sports? So, what is the objective? Maximum amount of money. Good. So we go back and define, they're talking about sports. What was the first sport they said? Football. X is football. And then Y will be soccer. Okay? And then it says that he can make $3 an hour for football and $4 an hour for soccer. Going through the next sentences, he says he wants to spend between 2 and 5 hours a week on soccer. There's a parameter. There's a constraint. You can spend 2 hours, you can spend 5 hours, or you can spend somewhere in between the two. So that was a soccer, right? Yep, soccer, so that's a Y. It's less than or equal to 5, but it's greater than or equal to 2. It says then he wants to give at least as much or more time to football than to soccer. More time, at least as much or more time to football. Greater than or equal to, very good. Sometimes you have to reread that a couple times to understand what they're saying. At least as much or more time. Okay. And then lastly, he had a total amount of time allotted for both practices. 15 hours, so X plus Y has to be less than or equal to 15. That gives me all of the constraints within the problem. Okay. So now I just go back and I start plotting intercepts. This one's pretty easy, and you can see where they are right away at 15s. So we split them up. Song stuck in my head. Masters of War. It's a Dylan song that Pearl Jam redoes pretty regularly on what they play it live. It's a really good song. Anyway, so now we've got those. What I'll probably graph first here is how it says X is greater or equal to Y. Isn't that the same thing as saying Y is less than or equal to X? It means the same thing, right? Now, that also means that this has a slope of what? 1. And when I intersect other lines, what does that mean about the X and the Y values? They're the same, very good. So if I split the difference here, I know that that line's got to go right through the middle. This ordered pair right away, where X and Y are the same, that add up to equal 15. 7.5, very good. Okay, now, on what side of that is X bigger than Y? To the right of it or to the left of it? To the right of it. Again, since you're going through the origin, you can't use that as a test point, but I got a point right here, 15, 0. Is 15 bigger than 0? Yeah. So it's true going that direction. So I know that it's going to shade this way, and it's shading down this way, as of right now. Now I just have to scale in my Y values. The Y values are somewhere in between 2 and 5. Well, I know that 7.5 is up here, which means 5 has to be below it. And then a 2 has to be below that. You okay with that? Now, using that y equals x line, or x is greater than or equal to y, we know that the x and y values have to be equal at each value that it hits. So I know that here, it hit 0, it hit the y equals 2. So what are your x and y values? 2 and 2, very good. The other one would be at 5 and 5. Here, I switched to the other line. Again, it's really nice when you have horizontal lines because you know that the y value remains constant. So in this case, when it hits that x plus y is 15, we know y is 5, therefore x is 10. So that order pairs at 10, 5. And the same deal with the 2. The y value remains constant and hits that x plus y is 15. If y is 2, what is your x value? 13. So my ordered pair here is 13, 2. And now the shading wise gives me in that trapezoidal region. Well, now this morning. Ordered pairs then would be at 2, 2, 5, 5, 10, 5, and 13, 2. 6 and 8 gives you, what was that, 14? 15 and 20 is 35. 30 and 20 gives you 50. 39 and 12 is 51, I believe. What's that? Oh, 30. Why did I say? I saw the 3S. So 39 and 8 is 47. And there's your maximum. How many hours is he supposed to play in football, and how many hours is he supposed to play in soccer? But the question was, how much money can you earn playing the sports? $50 a week, not bad. Yes, sir.
15 hours.
If you play football anywhere besides America, you're playing soccer. Football. Not the foosball. Bobby Boucher. Everybody got my question? Why? Nobody got my Bobby Boucher reference. You guys know what Bobby Boucher is?
Yeah, from
Right. Oh, his Mama Jean called it foosball. You know what I'm playing the foosball. Don't look at me like that. You understand the reference. You just don't want to acknowledge that I'm funny. I will say that is pretty good. I do like that. You guys are pretty funny. All right, other side. Betty works a maximum of 20 hours a week. Programming computers. What's that? That's what I said. Did I say 40? Oh. Anyway, so Betty works as a computer programmer and tutoring English. Apparently there's good money in computer programming and tutoring English. She receives $15 an hour for programming and $10 an hour for tutoring. She wants to work between 3 and 8 hours a week on programming, but to always give more time to tutoring. She has a heart. To maximize the amount that she earns, how many hours should she work at each job? What are her 2 jobs? Programming and tutoring. Which came first? Programming. So X will be programming, and then Y will be tutoring. Okay? How much money does she earn programming? And how much money does she earn tutoring? So your objective is to make the money. Now we start talking about the other bits. She says she wants to work between 3 and 8 hours per week on programming. That is a compound inequality. You want to work between 3 and 8. Oops, didn't show up at all. That's how you write that, between 3 and 8. It's including it. And then it says she wants to give more time to tutoring. So which one of those is tutoring? And it has to be greater than X. For our purposes, we can treat all of these as greater than or equal to or less than or equal to. I'm not going to throw in where you have to think that it's not technically getting a line and all that. So treat this as a greater than or equal to. That way you're technically have an intercept. Because you know, it would be dotted and it really isn't there. Yeah, it's the worst. And then, how many hours total does she have to work? Yes, ma'am. Which part?
Y greater than X.
Okay, so in this case here,
Like I know what a big fan, I just don't understand how it means an inequality.
you want, all right, so if you want to spend more time doing one thing versus in another, so if you have 5 hours to go fishing, but you want to go golfing, and you want to do more golfing than fishing, if you spend 5 hours fishing, you'd have to spend more than that golfing. So you'd have to spend 5.5 hours. So it has to be, that time allotment has to be greater than what the other one is. That's where that's coming from. Or not. Does that make a little bit more sense? Kind of, not really. All right. What do you got? What's that? Yeah, I'm getting that. She just asked me a quick question about this piece. Again, so another way, I'm trying to think of another way of explaining the greater than. When you...
Like just like, can it actually be like an inequality?
It is an inequality. Right? It's just, think of it this way as, you just basically think of this as, you want to spend more time doing this than this. You like to help people more than you like to program a computer. Even though you don't make as much money at it, it's just what you'd rather do. It's your preference to spend more time doing that. And I think there's no easier way to explain that. Let me think of something.
Just like how we solve.
Oh, I'll show you. I'll show you when we go to graph it. It's super easy. Okay? And then last bit here, ladies and gentlemen, come on. Last bit here is the total hours per week programming and tutoring. That's that last constraint that we throw in there, where you know that the addition of the two jobs that you're doing, the X plus Y, has to be less than or equal to 20. Okay? From here then is when we start to do all of our graphs. And this is where that the graph of that Y is greater than or equal to X comes into play. And it's really easy once you plot things through. When we do that, again, we go through our intercepts. Everybody okay that our largest intercepts are both 20s? Yeah. Okay. So I plot the 20s on both sides. 0, 20 here for the Y, and 20x, or 20, 0 for the X, and I connect them. It's moving inward because it's less than or equal to, because the maximum amount of time you can spend was 20 hours. Okay? Now, before I do the parameters of the 3 and 8, I look back at this. That's very similar to what we did a minute ago, where it was X, you want to spend more time playing soccer than golf or football, wherever it was. This one, if you treat this as Y equals X, it's a slope of 1, and it goes to the origin. When it hits this point here, Y equals X. So, what are the two numbers that are the same that add up to equal 20? So that's where we get the same amount here at 10 and 10. On what side of this is Y bigger than X? Well, because 0 is smaller than 20, 20 is bigger than X, so this way, it's got to go this way. All right? and then I put in my x values as my verticals. So you've got your x values then at 8, so it'd be to the left of that, and then your y value, or x value at 3. Since it hits that first line where y equals x, if the x value is 3, the y value has to be 3. Hits the x value of 8, the y value has to be 8. So here's 3, 3, 8, 8. And then when it hits the ones up top, if x is 3, 3 plus what is 20? 17. If x is 8, 8 plus what is 20? It's a vertical right there. Remember that vertical at 8? So now you've got your 4 pairs. 3, 3. 8, 8. 8, 12. 3, 17. Let's see. 3, 3, 8, 8, because they're vertical and they hit that line of y equals x. So from there, 45 and 30 is 75, I believe. Uh, 80 plus, or is it 120? You guys only have calculators to help me out here. Is this 200? Okay. 120 plus 120 would be 240. She should spend 8 hours programming and 12 hours tutoring to make this work. Don't die. Yeah. This thing is just y equals x. It's line y equals x. Yeah, because it's y equals x. Just remember, this point here is where y equals x. And if y equals x, that's basically the same thing as saying y plus y is 20. 2y is 20, y is 10. So if y is 10, x has to be. That's what I'm getting at. Okay. When the y equals x. You bravers.
Yeah. I got the right answer, but I think the entire equation is not sure how I did that.
Dumb luck. Dumb luck is better than no luck at all. Mr. Peter, what's up? It doesn't, but as long as, I mean, the idea here is that it knows it's telling you to look at the values up this way as opposed to anything down here. Plus, once you get this parameter here, you know you're not going to look at anything to the right of it anyway. Sometimes with these things, you don't need, if you start to look into it a little bit more, you can kind of manipulate it a little bit as you start to understand numerical value. And if you get that, it's fine. I know there are ways of thinking yourself out of these problems as well. So that's cool. If you can do that, that's awesome, man. And then the last one is the good old-fashioned snack bar. I like snacks.
I like more.
Oh, Lord help us. Anyway, ladies and gentlemen, come on. A snack bar cooks and sells burgers and hot dogs during football games. To stay in business, it must sell at least 10 burgers, but cannot cook more than 40. For some odd reason, it doesn't seem like a very, very populated football game. It must also sell at least 30 hot dogs, but cannot cook more than 70. I don't know why you can't cook that many, but whatever. They cannot cook more than a total of 90 items, They make 33 cents per burger.
What?
21 cents per hot dog. Low many of these items should they sell to make maximum profit?
Supposed to be how much?
Gee, what do you think?
I didn't know what this was. I don't know.
So, what's your objective? What's your objective? Profit. So, which one came first here, hot dog or hamburger? So, X will be my hamburger.
Hamburger.
I make 33 cents and 21 cents. Guys, you really don't need to be this loud doing this, okay? It talks about specific constraints, more of a parameter style again in this one. It says you must sell at least 10 burgers, but no more than 40. So your burger has to be somewhere between 10 and 40. Same idea for the hot dogs. Your hot dogs have to be somewhere between 30 and 70. And you can't cook more than 90 of them total. Yeah, sorry. I might have done it and just made my wife too much. That gives you all your parameters. As you go through this then, you'll notice it's a very quick one diagonal with 90s. Inward. We have 40 and 10 for the X. Well, 40 is about a little bit less than halfway. And then 10. So if the X value is 40 when it hits the line X plus Y is 90, what would Y have to be? 50. Now if the 10 hits that line, it would be okay. It's in between those values. Do the same thing with 30 and 70. Now 80 is here for Y, so 70 has to be below it. And then the 30 has to be below the 40. So here's our 30, and here's our 070. When those horizontals and verticals hit each other, those are the easiest ordered pairs to get because you know your X and your Y value. You don't have to do any math. I know that it's 10 and 30. I know this is 40 and 30. So I'm looking at this range here. I know that this is 1070. And then the last point we have to find is this one here. The Y value is 70. 70 plus what is 90? 20. So our points, 1030, 4030, 4050, 2070, and 1070. And then there's a lot of decimal buttons and stuff to press. Woo-hoo. Is it 4050? I'm just guessing.
Yeah. And then 23 points.
You only make $23?
Sign up with sharing.
Tomorrow you will have 2 questions. I think we'll call this a quiz. We will have 2 of them. 2 of these. 2 questions. Okay. What's that? Well, it's not today. Yes, there you are. All right. The idea we'll go with is we'll do 2 of them. I honestly haven't quite decided if I want to, because I know we have one more section to go, and then it would be our test. We've already had technically the quiz of the chapter, so maybe I'll just have it a little heavier weighted skill check, if you will, off that. But then we'll do the 2, and then we'll go with, we might start, because I don't think it would take more than 20, 25 minutes tops. What I did want to start a little bit of the next section though tomorrow. It is solving systems, but it's going to be a 3x3 system, X, Y, and Z. So it's just it's an added step of algebra. Okay? So we'll do that then tomorrow as well. Right? I think I have one more set of these lying around. You guys have used up just about every single one of the ones that I had. What's that? Ladies and gentlemen, I got a question over here. Stop talking. This one is really clean. You know how sometimes we have like 2 X's, Y's, it's nice, and you can substitute it and solve it. Because you're still solving it, it's just a lot easier. What's up? I can't count. I'll get it from you. Wait, or if you show over, come on, get yours. Oh, man. So, apparently, I just realized this. You did, so let's see here. Hey, you already did the first 2. Yeah, we know. What's the other is on? From where we're at, I would stay away from 3. I'd make sure you can do 4, and then I would go back over a ton of stuff. In the textbook itself, I'll re-put up the PDF from the 3.4. There are a couple in the actual textbook. Oops. Let's see. You can do the juice blend one, isn't too bad. Just remember that when you're mixing those through, how many quarts are in a gallon? How many quarts are in a gallon? It's 4, right? 4, yeah. So they switch your units. It's not that terrible if you want to look at that one also. But we did the filing cabinet one. We did the candy one. It does too much. It has an extra value in it we don't worry about. And then that one. So yeah, it looks like you've got the last one that I have then. So make sure you. My best guess for you guys to be able to do the 2 that I have left. I had to save some. Should have got more than that, but I had to save a few. The biggest thing that I can tell you guys to do when you're working on these types of problems is to go to your objective first and then figure out what they're talking about, use those values for your x's and y's. Okay? And then everything kind of falls into place from there. Okay? Thanks. Okay. Yes, sir.
Guys. This is like, you must answer at least 4 of the type A. Like, with the 4 and 7.
For what, which is the it'd be the objective because you want to maximize your look at the
Have you noticed that yeah. No, I just like very tired. Honestly, like, so like just like we're not confident ourselves and like, yeah, doing it, no,
It's an election.
How's it going? What'd you do Okay, I did not
A girl.
Oh, Mr. Sperry, you're here?
How you doing?
I've been lame.
He's been here for Hey, Brian, you look like you know, so is he like, could you actually, I would actually punch you. He said, yeah, you do. Yeah, you do. They don't. They don't. I can do better than that. They do it. They ain't shut up. What do you I found my headphones. Guess what they were? Where's that? Headphones. No?
Stop talking. It's all on the calendar. Everything for the class. Oh, I forgot this.